Welcome to the debate. When you look at an empty box, what do you see? Nothing? A void? Well, physics tells us that nothing is actually a very, very busy place. It's a seething ocean of quantum fluctuations. But usually, we just treat that ocean as a backdrop, a stage that doesn't really get involved in the play.
And, usually that assumption works perfectly fine. You don't need to account for the vacuum when you're calculating the trajectory of a baseball, or even when you're designing a standard combustion engine. The background is just, it's just the background.
True. But today, we're looking at a proposal that claims the stage is the play. We're dissecting the structured vacuum theory, specifically their new addendum forward document. And it asks a question that sounds simple, but is actually quite radical. If you change the shape of the container, the geometry of the vacuum, do you fundamentally change the energy accounting of the matter inside it?
It's a very polite way of saying they want to put an asterisk on Einstein's E equals mc squared. And as the representative of the, let's say, the rigorous critique today, I have to say right out of the gate, that is a very dangerous game. I mean, you don't tug on Superman's cape, and you don't mess with special relativity unless you have truly extraordinary evidence.
I'll take the other side. I'm arguing that this isn't messing with relativity. It's completing it. The proposal suggests a new effective energy equation, EFF equals nc squared psi t, where that psi t represents the topology, the actual shape of the space. I believe this is just honest spectral geometry. If the vacuum has structure, that structure must have an inertial cost.
And I believe it might be a mathematical sleight of hand that risks breaking the laws of motion. So, let's see if this theory holds water, or if it leaks.
Let's dive in. To understand why this addendum matters, we have to look at what they call their hardened definition. They are moving away from loose metaphors and anchoring themselves in something we absolutely know is real, the mode spectrum.
Right, and this is standard physics, but it bears repeating. Think of the vacuum like a guitar string. In open space, an infinite string, you can play any note, any frequency. It's totally continuous. You have an infinite range of vibrational modes.
Exactly. But what happens when you clamp that string? When you put it in a box, a cavity, or between two plates? You limit the notes you can play. You cut off the long wavelengths that just don't fit in the box. The spectrum becomes discrete. We know this happens. It's the whole basis of the Casimir effect.
I don't dispute the Casimir effect. If you put two metal plates very close together, the vacuum pressure outside is stronger than the limited vacuum pressure inside, and they get pushed together. That is standard QED. We measure it. It's real. But, and this is a big but, that's a force on the plates.
Okay, so if you accept that, just follow the logic of the addendum. The core postulate is that vacuum energy, EVAC, is simply the sum of all those allowed modes, all those notes on the string. So if the geometry changes the notes, it must change the total energy density of that space.
Sure. The energy density of the vacuum changes. I'm with you so far.
And that's where they bridge the gap. They introduce chi-t. It's not a new magic number, it's a ratio. It's the energy in your structured, bounded box divided by the energy in free open space. So chi-t equals E-bound, E-free. The argument is that this ratio doesn't just sit there, it actually acts as a multiplier on the effective mass of anything inside that box.
And that is the leap, that is the cliff I'm unwilling to jump off just yet. I mean, it's one thing to say the environment has a different pressure. It is entirely another thing to say that an electron floating in that box suddenly has a different rest energy because of the walls 10 microns away.
But why is that a leap? Mass is energy. If the background energy cost of existing in that space changes, the mass should reflect that. It's about the coupling between the particle and the field it lives in.
Because of how they try to calculate it. This brings us to the volumetric rest energy ansatz. This is where the math gets messy, and honestly where my skepticism meter hits the red zone. See, the paper relies heavily on this concept of transport speed, which they call VT. They write the equation as E equals mc3 VT.
Which is just a reformulation. If CT is CVT, it's the same equation. It's just more explicit about the velocity term.
But words matter, and dimensions matter. They are defining this VT by taking the Poynting vector, S, which is the flow of energy, like a river current, and dividing it by the energy density, U, the depth of the river. So V equals SU.
And that's the standard definition of energy velocity in classical E&M. I mean, if you open a textbook by Jackson or Griffiths, you'll find that definition.
In a textbook, yes, for a specific wave. But here's the first serious snag. And to their credit, the source material admits this is a problem. The ratio SU is frame dependent.
Right, okay. Explain that for the non-physicists. Why does frame dependence matter so much?
Okay, imagine a river. The water is flowing at 5 miles per hour. That's your VT. Now imagine I start running alongside the river at 5 miles per hour. To me, the water looks like it's standing still. The velocity is 0.
Right.
So if VT depends on the observer, if it depends on how fast I'm running, and you claim that a particle's mass depends on VT, then what you're really claiming is that the rest mass of a particle depends on who is looking at it.
That would violate special relativity. Rest mass must be invariant. It has to be the same whether you're standing still or flying past it in a spaceship.
Precisely. If I can change the mass of an electron just by walking past the experiment, we aren't doing physics anymore. We're doing magic. Or worse, we're returning to pre-Einsteinian ether theories.
I agree that the naive interpretation of VT is a trap. If you stick to that simple flow definition, you absolutely break relativity. But the addendum forward offers what they call a salvage path. They explicitly state that VT is a mnemonic. It's a shorthand for the spectral density. They aren't literally saying a physical velocity is slowing down. They're using it to represent the trapping of the modes.
Calling it a mnemonic feels like a retreat, though, doesn't it? It feels like saying, oh, our math blows up, so let's just call it a metaphor.
Look at the standing wave problem. This is where the whole division by zero issue comes in.
I knew you'd bring up the standing wave. It's the favorite target of the critics. Well, I have to. In a perfect standing wave like inside a high-quality microwave cavity, energy bounces back and forth perfectly. The net flow, the pointing vector S, is 0. The river isn't flowing. It's just sloshing back and forth but staying in place. So if you plug S equals 0 into their formula, you're dividing by 0. The energy goes to infinity. The math effectively explodes.
If you stick to the fluid dynamics view, yes, it explodes. But look at the hardened definition in the text. This is why the addendum was written, to fix this specific misunderstanding. They pivot to spectral counting.
How does counting solve the infinity problem?
Well, think about the standing wave again. You have nodes, dead spots where the field is 0. But the modes, the allowed frequencies, they still exist. The spectrum doesn't vanish, it just becomes discrete. You can still count the allowed states.
So you're saying the denominator is never actually 0 because they just switch definitions when it gets dangerous?
No, I'm saying they switch to a more fundamental definition. Chi-T is defined by the mode count, not the flow. The mode count in a standing wave is finite and well-defined. So Chi-T remains a finite number, and the energy EF remains finite. The so-called explosion is an artifact of using the velocity shorthand, not a failure of the topological argument itself.
Okay, I'll grant that the spectral approach is cleaner. It saves the math from immediate collapse, but it still leaves us with the elephant in the room. Point 2, Lorentz invariance. Even if the math doesn't explode, you are modifying E equals mc squared. You are introducing a factor that changes based on where you are.
The text calls this scope discipline, and I think this is the strongest conceptual defense they have. It frames the theory not as a rewrite of the laws of nature, but as a clarification of their application.
Explain scope discipline to me in a way that doesn't make Einstein roll over in his grave.
Look, Einstein is safe. Here's the argument. Special relativity describes free, empty, unbounded space. It assumes a flat, infinite background. It assumes you are nowhere near a boundary.
Fair enough. It's an idealized vacuum.
But the moment you build a box, a cavity, a waveguide, a capacitor, you have broken that symmetry. You have created a preferred frame, the rest frame of the box itself.
Okay, that's true. A box defines a local coordinate system.
Exactly. The addendum argues that Chi-T applies only in the rest frame of that structure. It's not a universal constant changing the laws of physics everywhere in the cosmos. It's a local interaction parameter. In free space, the box is gone. Chi T becomes 1, and you get E equals mc2 back perfectly.
So it's context-dependent physics.
Yes, it's saying that E equals mc2 is the special case for an unstructured vacuum, and E equals mc2 chi T is the general case for a structured one.
That is a very seductive argument. It preserves the old laws as a limit of the new ones. But let's look at the consequences of that context. If chi T varies, say as I move from the center of the cavity toward the wall, you are effectively creating a scalar field that permeates that box.
A scalar field that maps the topology, yes, that's the idea.
But mathematically, that looks exactly like a conformal metric. You're basically rescaling the fabric of space-time, g mu nu, by this factor chi T. If you do that, you are implying that electromagnetic matter couples to a different metric than gravity does.
That puts us in scalar tensor theory territory.
It does, and that triggers point 3. And this is the one that usually kills these kinds of theories, the fifth force.
Ah, I see where you're going. If the energy changes with position, there has to be a gradient.
Elementary mechanics. Force equals the negative gradient of potential energy, F equals grad E. If the effective mass drops as I get closer to the wall, there must be a force pushing me toward the wall, a fifth force. We have tested gravity and atomic forces to incredible precision. ETVIS experiments, atomic clocks. I mean, if there was a rogue force pushing atoms around based on vacuum geometry, wouldn't we have seen it?
But we do see it. That's what the Casimir force is.
You keep conflating them. The Casimir force is a pressure on the plates. It's a macroscopic push on the boundary material. This theory claims the force acts on the atoms inside the vacuum.
The Hardin thesis argues that distinction is artificial. Look, if the vacuum energy density is lower between the plates, nature wants to minimize energy. Usually the plates move to do that. But if you have a particle inside and its self-energy is coupled to that mode spectrum, it should also feel a gradient. Why should the particle be immune to the pressure that the plates feel?
That is the hypothesis. But notice the magnitude. Casimir forces are tiny. This theory suggests that in high-intensity environments, like magnetars or localized nanostructures, this chi-T factor could be significant. If chi-T deviates from 1 by even a fraction of a percent, the spectral lines of an atom inside that cavity would have to shift.
And the source material welcomes that challenge. They explicitly list precision spectroscopy as a stress test. They aren't hiding. They say, put a cesium atom in a high Q toroidal cavity. Measure the clock frequency. If it shifts, we're right. If it doesn't, we're wrong.
I do respect that. A theory that offers a kill switch for itself is a theory with integrity. But let's talk about the complexity of that calculation. Point 4. The scattering matrices.
The scattering formalism. Yeah, this is the heavy lifting of the paper.
Yes, you talk about psi-t like it's some simple number. Just multiply by psi. But anyone who calculates Casimir forces knows that geometry is a nightmare. If you have a sphere, a plate, and some corrugations, the spectrum changes in wild nonlinear ways. You can't just boil it down to a single scalar multiplier.
You can if you use the determinant method. The text references the reflection operators R1 and R2. The math shows that the energy comes from the integral of the log determinant of these matrices.
The log det formula? Standard for Casimir energy, I admit.
Correct. And in that formula, the geometry enters multiplicatively inside the determinant. So psi-t isn't just a number pulled out of a hat. It is computed. It is the summary statistic of that complex scattering interaction. It just tells you, this specific mess of geometry has, say, 1.1 times the energy density of free space.
So sheet T is basically an equivalence variable. It allows you to pretend the complex cavity is simple just by adjusting the energy scale.
Precisely. It allows us to maintain the clean form E equals mc squared chi T as an effective field theory description. It bundles all the complexity into that one coefficient.
Okay, mathematically I'll grant you that is permissible. Physicists love effective theories. But I have to circle back to the branding.
The branding?
Yes. They insist on writing E0 equals mc squared VT.
You really hate that equation.
I do. It just feels like marketing. If the spectral definition,
The counting of modes is the real rigorous physics. Why keep the velocity formula? It invites people to plug in numbers that don't make sense. It invites the division by zero critique we talked about earlier.
I think it's about intuition. C2 is powerful because it represents linearity. Light travels in a line. But C3VT, that implies volume. It implies circulation. In a cavity, energy isn't going anywhere. It's circulating. It's self-interacting.
Trapped energy?
Right. We know trapped energy adds to mass. A hot box weighs more than a cold box. This theory just extends that logic to the vacuum itself. If the vacuum modes are trapped by the topology, they contribute to the inertia of the system. The VT term is trying to capture that sense of slowed circulation or volumetric delay.
That is a poetic way to put it. C2 is for going places. C3VT is for staying put.
Exactly. It's the energy cost of occupancy. And think about the implications. If you can manipulate VT, if you can manipulate the topology, you can manipulate the effective mass.
Okay, I will give you energy cost of occupancy. That's a fascinating concept. But as a skeptic, I have to look at the field-theoretic embedding. You can't just change energy density U without changing momentum density S and the stress tensor. Maxwell's equations are a package deal. You pull one thread, the whole sweater unravels.
The proposal suggests this comes from a modified Lagrangian. Essentially, the vacuum inside the cavity acts like a dielectric material, an effective medium.
See, if they frame it as an effective medium theory, I'm 100% on board. We do that all the time in optics. Light slows down in glass. The vacuum in a cavity acting like glass due to mode restriction? Plausible.
But here's the kicker. If it acts like a medium, and the particle has to drag that medium interaction around it,
then it looks like effective mass.
Then semantics don't matter. If it looks like mass, and moves like mass, and creates inertia like mass,
then we're just arguing over the label on the jar, not the pickles inside.
That's my point. Whether you call it new physics or interaction energy, the prediction is the same. The energy accounting changes inside the structure.
But the magnitude is where the rubber meets the road. If this is just a tiny correction, it's a footnote. But the addendum does hint at larger implications in extreme environments.
Yes, magnetars, plasma confinement, maybe even early universe cosmology. Anywhere you have extreme energy density and tight topological constraints.
So, where do we land? After tearing apart the addendum, what's the verdict?
My verdict is that the vacuum is not neutral. We know boundaries cut the spectrum. The structured vacuum theory simply demands we finish the equation. If the spectrum changes, the energy must change. And Shiti is the bill for that change.
And my verdict is cautious interest. The spectral geometry defense in the addendum is miles better than the initial transport speed argument. That was shaky. This is built on real math.
But
I am still keeping my copy of Special Relativity on the shelf unmodified. I think writing E equals MC3 VT is provocative to the point of being distracting, and I worry that claiming a change in rest mass rather than environmental potential will just alienate the very physicists they need to convince.
fair. But you have to admit, the idea that context is geometry is beautiful.
It is. And the fact that they're calling for high-precision lab tests using atomic clocks and resonant cavities means we won't have to guess forever.
If they find a deviation, if they find that psi t is not 1,
then we have to rewrite the textbooks. And I'll be the first to buy the new edition.
we'll keep a seat open for you at the Nobel ceremony.
Don't book the tickets just yet, but it is definitely a space worth watching.
Thank you for joining us on this deep dive into the structured vacuum. It's complicated, it's controversial, but it reminds us that even empty space is full of surprises.
Always a pleasure to argue the physics.
Join us next time on The Debate.
I'm looking at a formula right now that is physically hurting my brain. I want you to look at this line. It's right in the abstract of the main document we're covering today.
Oh, I see it. Yeah, it jumps right out at you, doesn't it? It almost looks like a typo.
A typo. It looks like heresy. It's absolute scientific heresy. It says E equals MC cubed.
Yeah. You know, if you were to write that on a chalkboard in a freshman physics class, you'd probably get an eraser thrown at your head.
Exactly. I mean, Einstein gave us E equals mc squared. That is the law. It's the most famous equation in the world. It's on T-shirts. It's, in cartoons. It is the bedrock of how we understand the universe. Energy equals mass times the speed of light squared.
And that's it. Full stop.
But today we are looking at this stack of documents, specifically something called a volumetric rest energy ansatz and a very, very spicy addendum forward that dares to suggest maybe Einstein didn't get it wrong, but that he maybe stopped too early.
Incomplete is the word the author uses. And you're right, this stack of papers is just fascinating because it doesn't read like a dry academic paper. It reads like a fight.
It really does. It has the tone of a manifesto, or, like you said before we started, a smackdown.
It's a defense, a very pointed one. The author is clearly, and I mean clearly, responding to peer reviewers, the referees, who just absolutely hated this idea. You can feel the frustration in the text.
You can see the scars.
You can.
Right.
And so they're being incredibly defensive, but also incredibly rigorous. They're trying to prove that if you take the vacuum seriously, not as empty space, but as a thing, a physical medium with structure, then you have to update the energy ledger of the universe.
So that's our mission for this deep dive. We're going to get into this controversy. We're going to figure out why in the world anyone would dare to write cubed. And we're going to tackle the big question. Does the empty space inside a box actually change the mass of the stuff you put inside that box?
It sounds like something out of science fiction. But by the end of this, I think you'll see that the author's argument is that it's actually just honest bookkeeping.
Honest bookkeeping. I like that phrase. But before we get to the books, we have to look at the ledger itself. We have these 3 documents, the addendum forward, the ansatz itself, and then an addendum after. And the tone, man, the tone is just not what I'm used to in physics papers.
It's combative. I mean, usually academic writing is so passive. It is suggested that, or the data indicates a possibility that.
Are they very cautious?
This is totally different. This author is explicitly moving from what they call intuition to what they call hardened spectral geometry. They're basically saying, look, you attack my initial metaphor, so now I'm going to hit you with the hard math so you can't wiggle out of it.
It's like watching a lawyer cross-examine themselves before the prosecution can even get to them. And that core question they're trying to answer is just, it's fascinating. Does the energy spectrum of the vacuum, the nothingness, change when you put walls around it?
And the follow-up.
And if it does that change the effective mass of the things that are inside those walls?
That is the multi-trillion-dollar question, isn't it? Because if the answer is yes, even a tiny bit, then our understanding of energy storage and maybe even things like propulsion or inertia gets a pretty significant update.
Okay, so let's unpack this thing. We have to start with the proposal itself.
Yeah.
The volumetric rest energy ansatz. Break that title down for me. Ansatz sounds like a heavy metal band from the 80s.
It does, doesn't it? Ansatz is just a sort of fancy German word that physicists love to use. It just means an educated guess, a starting point that you use to solve a problem. You make an ansatz.
So it's like a hypothesis.
A working hypothesis, exactly. And the starting point here is all about the nature of light itself.
Okay.
So let me ask you, how do you picture a photon? When you think of light moving through space, what's the image that pops into your head?
I usually picture a laser beam. A really thin red line, one-dimensional, like a string pulled tight across the universe from point A to point B.
Right. And that's the ray model of light. It works great for designing lenses and mirrors, but the author here says, stop doing that. You have to stop. Light isn't a line. It's a field.
An electromagnetic field.
Exactly. It has an electric component that's waving one way and a magnetic component waving at a 90-degree angle to it. It's a 3-dimensional event.
So it has width, it has depth. It's not just a point on a line.
It takes up space. It is volumetric, and the author's whole argument starts there. They say, when this 3D volume of energy is moving through free space, the infinite empty void, it moves in a straight line at speed c. No problem. Einstein is happy. The math works.
But we aren't always in free space. That's the catch.
No, we're not. Most of the time we're inside things. We're in a room, inside a microwave oven, or in a lab between 2 metal plates. We are in what the paper calls a bounded topology.
A bounded shape. And this is where the trouble starts for old Einstein.
This is where the author introduces this new term, the topology factor, which they call chi-t. That's the Greek letter chi subscript t.
Okay, chi.
They argue that when you trap that volumetric field inside, say, a donut shape, a toroid, or a sphere, The energy isn't just zipping in a straight line anymore. It can't. It's circulating. It's bouncing off the walls. It's interacting with the boundary. And that, they claim, changes the effective transport of the energy.
All right, so that brings us back to the new formula. And I want to walk through this very slowly because, again, seeing a 3 next to the C just freaks me out. It feels fundamentally wrong.
Let's break it down. The formula, as written, is E naught. So rest energy equals m times c cubed divided by Vt.
Okay, so E0 equals mc cubed over Vt. Right, so m is mass. C cubed is the speed of light to the power of 3. And it's divided by this new thing, Vt.
And Vt is defined, at least in this first intuitive part of the paper, as the averaged volumetric transport speed of the energy inside that bounded space.
Okay, hold on. My dimensional analysis alarm is just ringing off the hook right now. Energy is joules. And joules, fundamentally, are mass times velocity squared, kilograms times meters squared per second squared.
Correct, an mv squared term.
So if I have c cubed, that's velocity cubed. And I divide it by another velocity, vt.
Do the math. You have v times v on top. And you have 1v on the bottom.
One of the v's cancels out. So I'm left with b squared.
Bingo.
Huh. So the units, they actually work.
They work perfectly. It's dimensionally consistent. The author knew people would panic at the sight of c cubed, so they're very, very careful to explain this. What the formula is really saying is this. Take Einstein's beautiful, perfect mc squared and just multiply it by a new factor, a ratio.
What's the ratio?
The ratio is c divided by vt.
Oh, I see that now. Okay. It's mc squared times the quantity, c over vt.
Exactly. That whole c cubed thing is a bit of a provocative way of writing it. It gets your attention. But the real physics is in that ratio. That's the chi-t factor.
So all the new physics is hiding inside that one term, chi-t equals c over vt.
And here's the real kicker. Here's the aha moment. What is the absolute unbreakable speed limit of the universe?
The speed of light, c. Nothing with mass can reach it. Nothing can go faster.
Right. So this transport speed inside the box, this vt, what does it have to be?
It has to be less than or equal to c. It can't possibly go faster.
It's constrained. 0 is the bottom, c is the top. So now look at your fraction again. You have c in the top, and on the bottom you have a number that is guaranteed to be equal to or smaller than c.
So if the bottom number is smaller than the top number, the result is bigger than 1.
Always. Or equal to 1 in the limiting case.
Wait a minute. Let's play this out. Let's say I'm in deep space, totally free space. The energy transport is just c.
Right. Vt equals c.
So c divided by c is 1.
And your equation becomes E equals mc squared times 1. You get Einstein back. The theory is safe. It doesn't break standard relativity in open space. It has what we call the right correspondence limit.
But, if I build a box, a really specific, tight, restrictive box, and I can somehow slow down the effective transport of the electromagnetic field inside it, let's just say, for argument's sake, to half the speed of light.
So Vt is now 0.5 c.
Then my ratio is c divided by 0.5 c. The c's cancel, and I'm left with 1 divided by 0.5.
Which is the same as multiplying by 2.
Correct. The topology factor, chi-t, becomes 2. So the equation becomes E equals mc squared times 2.
The author is suggesting that the geometry of the container can literally amplify the effective rest mass energy of the vacuum field that's trapped inside it.
That's heavy. That's literally making things heavier. You're telling me that if I stand in the wrong shaped room, I effectively have more energy mass?
Well, if you were a pure electromagnetic field, then yes, that's the claim. The structure of the vacuum, as defined by the walls, acts as a multiplier on the energy content.
But wait a second. That feels like a violation of conservation of energy. You can't just create energy out of geometry. That sounds like a perpetual motion machine? Or, magic.
And that is exactly why the referees, the anonymous peer reviewers for the journal, attacked this paper with, let's say, extreme prejudice.
I can imagine.
They saw this mass amplification idea and they went straight for the throat.
So did they attack the math, the dimensional analysis?
No, the dimensional analysis is solid. They attacked the premise. Specifically, they attacked this variable, this Vt, this whole concept of the speed of energy.
This is section 2 of the paper, which the author themselves titles The Problem with Speed. Or, my favorite, The Soft Target.
Right. And you know what? The critics had a really, really good point.
They were right.
On this specific issue.
Yes.
Because this idea of the speed of energy is a conceptual trap. It's slippery.
How so? I mean, speed seems pretty straightforward. It's distance over time. I drive my car at 60 miles an hour. Why can't a packet of energy drive at a certain speed?
In classical mechanics, sure, it's easy. But in electromagnetism, it gets very weird very fast. The critics pointed to something called the pointing vector.
I saw that in the source material. It sounds like a pointing finger, but it's spelled Poynting.
Yep, named after John Henry Poynting. It's a vector, so it has a direction and a magnitude, and it basically represents the directional flow of energy in an electromagnetic field. Let's call it S.
Okay, S is the flow.
And then you have the energy density, which we can call U. So, classically, you might try to define the velocity of that energy as the flow, S, divided by the density, U.
S over U, that makes intuitive sense to me. It's like calculating how fast a river is moving. You measure how much water passes a point, that's the flow, and you divide it by how much water is actually there, that's the density.
It's a great analogy. But now, here's the problem. Imagine that river isn't flowing downstream anymore. Imagine it's a wave pool at a water park.
Okay, a standing wave.
The perfect standing wave. Imagine the waves are bouncing back and forth between the walls perfectly. The wave going left is the exact same size and shape as the wave going right.
Right, like when you slosh water in a bathtub and it just goes up and down the middle but doesn't seem to be going anywhere.
Exactly that. In a perfect standing wave, the left moving energy and the right moving energy cancel each other out in terms of transport. So what is the net flow of water past a certain point in the middle of that tub?
It's zero. The water is moving up and down like crazy, but it's not actually going anywhere.
Precisely. The net flow, S, is zero. But is the bathtub empty?
No, of course not. It's full of water. And it's full of energy. It's sloshing around violently.
So the energy density U is huge. It's non-zero. But the net flow, S, is zero. Now put those values back into your speed formula. What is S divided by U?
0 divided by a huge number is just 0.
The velocity is 0.
No, if we put 0 into our new Einstein equation, c cubed divided by 0, infinite energy, the equation blows up.
You get a singularity, a division by 0 error.
Okay, I can definitely see why the referees were angry now. If this theory predicts that my microwave oven contains infinite energy just because it has standing waves inside, which it does, then it's a bad theory.
It's a fatal flaw in that formulation. It would imply that anytime you perfectly trap energy in a resonant cavity, the universe should just collapse into a black hole.
Yeah.
Which, it doesn't.
Did the author just give up? Did they pack up their papers and go home after that critique?
No. And this, for me, is the most fascinating part of this whole deep dive.
Okay.
The pivot.
The pivot.
In the addendum forward, the author basically comes out and says, okay, you got me. You found the hole in the boat. But here's the thing. That boat was just a model I built for you to understand the ocean.
What does that even mean?
The author claims that the whole speed definition, this VT, was never meant to be the real physics. They call it a mnemonic, a visual aid, an intuition bridge.
An intuition bridge. That sounds a lot like I was dumbing it down for you simpletons and you took it too literally.
That is exactly the subtext. It's a bit arrogant, maybe, but that's what they're saying. I use the simple concept of speed to help you visualize the slowing down of energy transport, but you guys obsessed over the pointing vector math and completely missed the deeper point.
Isn't that a bit of a cop-out, though? Oh, I was just kidding about the part of my theory that you proved was wrong.
It feels like it at first glance. It really does. But what they do next is substantive. They don't just hand-wave it away. They abandon the soft target of speed and retreat to what they call a hardened definition. They shift the entire foundation of the argument from fluid dynamics to spectral geometry.
Spectral geometry. That sounds much more expensive and much harder to argue with.
It is much more rigorous. And this is where we get into section 3, the hardened definition. And to really get your head around this, we have to stop thinking about rivers and wave pools, and we have to start thinking about choirs.
Choirs. Okay, I'm with you. Let's talk about choirs.
The author argues that the vacuum, what we think of as empty space, isn't just a silent stage where the play happens. It's not just nothing. It is a spectrum of modes.
Okay, define modes for me in this context.
Think of a guitar string. If you pluck it, it vibrates. But it can't just vibrate any old way at once. It has to vibrate in a way where the ends at the nut and the bridge are pinned down. They can't move.
Right. It has a fundamental frequency, the main note.
And it has harmonics. You can get a vibration that's half the string length or a third of the string length and so on. Those specific allowed shapes of vibration are called modes.
Okay, so a set of allowed patterns.
Exactly. Now apply that same idea to the vacuum of space. The electromagnetic vacuum is constantly bubbling with energy. We call them zero-point fluctuations. It's a quantum effect. It's like a choir that is constantly humming every possible note at once.
And this is in free space.
In free space, yes. The choir is infinite. It can sing any frequency, From an infinitely low bass rumble to an infinitely high soprano screech, there are no walls to stop the sound. It is a continuous, unbroken spectrum.
But then we come along and we build a box.
We build a box, a resonant cavity.
And suddenly the choir is no longer in an open field. It's in a room.
Precisely. And the walls of that room dictate which notes are allowed to be sung. Just like the guitar string, the electromagnetic waves have to fit inside the box with the right boundary conditions. You can't fit a wavelength inside the box if that wavelength is bigger than the box itself.
So we've effectively silenced the really low bass section of the choir.
You've silenced some notes, and you may have enhanced others. You have chopped up the continuous spectrum into a discrete or quantized spectrum. You have changed the density of states.
So the structure of the vacuum that they keep talking about is really just the playlist. It's the set list of which notes are allowed to be played in that specific venue.
That is a perfect way to describe it. The geometry of the container defines the density of the spectral states inside. And here is the big pivot. The author redefines that topology factor, chi-t. It is no longer about speed at all.
So what is it now?
Now, chi-t is simply the ratio of the total energy of all the allowed modes inside the box, divided by the total energy of the modes you would have found in that same volume of free space.
So chi-t equals E bound divided by E free.
It's just a counting exercise. You count up the energy of the choir singing in the room, and you compare it to the energy of the choir that would have been singing in that same space if the room wasn't there.
And this new definition, this completely avoids the divide by zero problem with the standing waves.
Completely. There is no velocity vector that can go to zero anymore. It's just a scalar ratio of two energy values. It's dimensionless, it's entirely dependent on the geometry, and it's mathematically rock solid.
So by switching the argument from how fast is the energy moving to how many energy states are there, they sidestep the entire critique.
They harden the target. You can't attack the concept of spectral density in the same way you can attack a slippery definition of velocity.
And I have to ask this because I'm playing the role of the skeptic here. Are we just making this all up? The vacuum has a playlist. The choir changes its tune. It sounds very poetic, but is it actual physics? Or is this just a really fancy mathematical trick to save a bad theory?
That is the million-dollar question, and the author anticipates it. They know it sounds like metaphysics, which is why they slam this next point home in Section 4. They call it the Casimir anchor.
The Casimir effect. I see this pop up in science fiction all the time. You know, zero-point energy modules, that kind of thing. But what is it really?
It's one of the weirdest, but also one of the most proven predictions in all of quantum mechanics. A Dutch physicist named Hendrik Casimir predicted it back in 1948, and it freaked people out.
So what's the experiment? What's the setup?
It's beautifully simple. You take two metal plates, you make them perfectly flat, perfectly smooth, and perfectly conductive. You put them in a perfect vacuum. No air, no charge, no magnetism, just dead, empty space.
Okay. Two plates and nothing.
And then you bring them really, really close together. We're talking microns apart, a fraction of the width of a human hair.
And what happens?
They push together.
By themselves.
By themselves. A physical force appears out of what should be nowhere, and it pushes the plates toward each other.
And you're sure that's not just gravity?
Gravity is millions and millions of times too weak to account for it at that scale.
And it's not some kind of static electricity?
Nope, the plates are electrically neutral.
So, what in the world is pushing them?
The vacuum is. Or more accurately, the imbalance of the vacuum energy. Remember our choir analogy.
Yeah, the infinite choir in free space.
Outside the two plates, the infinite choir is singing every possible note. Low notes, high notes, huge wavelengths, tiny wavelengths. They are all pushing on the outside surfaces of the plates from all directions.
Okay, a pressure from the outside.
But between the plates, that tiny gap acts like a room with very specific dimensions. The space is too small for the big wavelengths to fit. The low notes from the choir can't exist in that gap. So there are fewer modes, fewer notes, pushing from the inside out than there are pushing from the outside in.
So the outside pressure is stronger than the inside pressure. The outside wins.
The outside pressure wins, and it literally crushes the plates together. This is not a theory. It is a real measurable force. We have to account for it in nanotechnology all the time because it causes tiny machine parts to stick together when they're not supposed to.
So the author's argument is, look, we already know for a fact that putting up walls changes the energy of the vacuum. We can measure the force it creates. I am not making this part up.
Exactly. Their argument becomes a very simple, very powerful, logical syllogism. Premise 1. Boundaries change vacuum energy. That's proven by the Casimir effect.
Okay.
Premise 2. Energy and mass are equivalent. That's proven by Einstein's E equals mc squared.
Right.
Conclusion. Therefore, boundaries must change the effective mass-energy accounting of a system.
I see the quote here. This is not metaphysics. It is spectral geometry applied honestly.
That's the line. They're basically saying, I'm not inventing magic, I'm just demanding that you do the accounting properly. If you ignore the energy contribution from the Casimir effect in your total mass energy equation, you are doing bad bookkeeping.
Okay, that feels much more solid. That feels way more robust than the initial speed argument. Connecting it directly to Casimir gives it a real pedigree. It's not just some guy with a new idea.
It grounds the entire proposal into experimental reality.
But the referees, the critics that are kind of the villains of this paper, they didn't go down without a fight. Section 5 is what you call the smackdown.
And it really is a smackdown.
Yeah.
The author just lines up the objections and knocks them down one by one.
I want to go through these because I think they sound like the kind of things a smart listener would be yelling at their radio right now. So let's play referee.
Let's do it.
Objection number 1, this violates Lorentz invariance. This is the big sacred rule of relativity, right? The laws of physics shouldn't change just because you're moving at a constant speed. If this box has some special absolute energy value, doesn't that break the rule?
It's a very standard and very good objection. Relativity says there is no preferred frame of reference in the universe. If you say this box has an absolute energy value of X, you are implicitly defining the box's location as a preferred frame.
So how did the author get out of that one? It seems like a pretty big hole.
With a very sharp and, I think, very clever retort, they say, Lorentz invariance applies to free vacuum.
And we are not in free vacuum.
We are in a box. A box has a frame of reference. The walls of the box define the frame.
So it's like saying, the laws of the open highway say you can drive anywhere you want. But if I build a garage, I can't drive 60 miles per hour inside the garage. The walls impose new rules.
That's a perfect analogy.
Yeah.
And you can't complain that the garage has a specific location in your neighborhood. You built it there. The author writes, and this is a direct quote, Casimir physics is explicitly frame conditioned because boundary conditions are, by definition, frame conditioned.
So the box itself breaks the symmetry of free space, so the math is allowed to reflect that broken symmetry.
Exactly. You can't demand that a finite physical box behaves like an infinite featureless void. That's just illogical.
Okay, so that objection is handled. Objection number 2 we already touched on. Standing waves make the energy flux 0.
And the author's response to that one is basically irrelevant.
That's it.
That's it. We aren't using flux anymore. We are counting modes. The choir is still singing. Even if the sound isn't leaving the room, the energy is there. Next question.
Wow, they really just brushed that one off. That must have felt good to write.
Once they moved the foundation of the argument to spectral geometry, that whole line of attack just became obsolete. It was attacking the ghost of the old theory.
All right. Objection number 3. Casimir forces don't scale by a simple constant. The critics here are saying, look, you can't just have one magic number, this chi-t, that works for everything. Nature is messy. The force changes with distance and shape in complicated ways.
And the author agrees. This is what I love about the paper. They don't try to deny it. They lean into it. They say, you're absolutely right. Chi-t is not a universal constant like pi or the speed of light. It's a geometric parameter.
It depends on the shape of the box.
If you change the box from a cube to a sphere, Chi-t changes. If you change it to a toroid, it changes again. If you change the material of the walls from perfect conductors to something else, it changes. The author says this isn't a bug in the theory, it's a feature. It is precision.
So it means we have to calculate it from scratch for every single shape we want to analyze.
Which is exactly what we have to do in real engineering all the time. You don't build a bridge assuming every shape of beam holds weight the same way. You do the calculation for that specific geometry. This is no different.
Okay, final objection. This one sounds serious. Objection 4. This is a fifth force.
Ooh, the fifth force accusation. That is the ultimate insult you can throw at a theoretical physicist.
Why is it such a bad thing?
Because we have 4 fundamental forces that we know of. Gravity, electromagnetism, and the strong and weak nuclear forces. That's the standard model. If you come along and propose a fifth force, you are usually seen as a crank. Someone who's just making up a magical force to make their broken equations balanced.
Like adding a fudge factor.
A fudge factor for the entire universe, yeah. The critics are essentially saying, you're inventing a magical push or pull out of thin air just to make your numbers work.
So how does the author defend against that? That's a heavy charge.
By using a concept they call scope discipline.
Scope discipline. That sounds like something a project manager would say.
It basically means stay in your lane, the author says. I am not, under any circumstances, claiming this force exists everywhere in the universe. It only exists inside the boundaries of a conditioned system.
So in free space?
In free space, the boundaries are gone, JT returns to exactly 1, the force vanishes, and the math reverts perfectly to standard Einsteinian relativity. So it's not a new fundamental force of nature. It's an emergent property of confinement.
It's strictly clause dependent. If there is a box, then there is an effect. No box, no effect.
Precisely. It's not overturning the existing laws of physics. It's just reading the fine print in the contract that we've been ignoring.
So we've survived the cross-examination. The theory seems mathematically sound, at least in this hardened form. It has answers for the major criticisms. But does it actually matter?
Yeah, there's always the question, isn't it? The big so what?
Right. This is section 6 of the paper, Implications and Predictions. If I have a toaster on my counter, is its mass being amplified by the vacuum energy inside its metal shell?
In principle, yes. A tiny, infinitesimally small bit, but not enough to ever notice. You wouldn't be able to measure it. You wouldn't feel it when you pick it up. The Chidec factor for a toaster is probably 1.000, with a whole lot of zeros.
So where would we see this? Where could we actually find a chai tea that's big enough to matter?
To get real measurable effects, to get that mass amplification we talked about, you need to find or create extreme conditions.
Right.
You need to restrict the vacuum modes so severely that the difference between the inside and the outside is huge.
The paper gives a few examples. The first one is magnetars.
Right. Magnetars are a type of neutron star. The magnetic fields around them are so mind-bogglingly strong, trillions of times stronger than Earth's, that the fields themselves act like walls. They structure the vacuum.
So the magnetic field lines are creating a box without any physical walls.
Precisely. The field lines are so dense and so ordered that they constrain which vacuum modes can exist there. The author suggests we might already be seeing the effects of this in the energy output of magnetars, but we just haven't labeled it correctly. We see these weird super-energetic bursts, and we call it unknown physics, but it might just be the topology factor at work in an extreme environment.
What about something we could build here on Earth? I want to build the mass amplifier machine.
Well, our best bet is probably in nanotechnology. The paper talks about high-precision Casimir geometries. We can now build structures at the nanoscale that are so small and so perfectly shaped, the vacuum pressure from the Casimir effect is a dominant force, not some tiny afterthought.
So we could build a tiny box where this effect is huge.
That's the hope.
Oop.
A box designed specifically to maximize the difference in the density of states.
The paper actually gives some numbers to play with. Let's run them just to get a feel for the scale.
Okay, let's do it.
It says if we can build a cavity that gets the effective transport speed, v-t, down to 0.9c, so we've only slowed down the vacuum transport by 10%.
Right. In that case, your chi t factor, c over vt, would be c over 0.9c, which is about 1.11.
So we get an 11% boost in the effective energy.
That's decent. I mean, an 11% gain in energy efficiency or storage from geometry alone would be a revolution.
But then it gives the big one. What if we can get VT down to 0.5c?
If we can build a structure that slows the effective transport to half the speed of light,
then chi t is c divided by 0.5c. It becomes exactly 2.
you double the effective energy. A 100% increase.
100%. What would that even mean for, I don't know, energy storage or propulsion?
Well, think about it. If you can manipulate the effective mass energy of a volume of space, that's the holy grail of advanced propulsion. Let's think about inertia. Inertia is just the resistance to a change in motion, and it's directly related to mass.
Right. Heavy things are hard to push. Easy.
But if you can make the space in front of your ship lighter by changing the geometry and the space behind it heavier, you're talking about inertia modification.
You're talking about metric engineering. That's a term from general relativity.
You are engineering the metric of space-time, not with gravity, but with electromagnetic boundary conditions, with walls.
That sounds suspiciously close to the Alcubierre warp drive concept.
I wouldn't go that far just yet. That's a whole other level. But it opens the door to the idea that mass isn't just an intrinsic property of stuff. Mass is also a property of where the stuff is and what shape its container is.
And the author doesn't just leave it at speculation. They put their neck on the line. They propose a concrete, falsifiable test.
Yeah, high Q toroidal cavities.
A perfect superconducting donut.
A donut that can ring like a bell. A high Q or high quality factor cavity is one where electromagnetic waves can bounce around inside for a very long time without dying out. It's a very pure resonator.
So what's the experiment? What do we measure?
It's elegant. You build a perfect toroidal cavity, and you precisely measure the vacuum pressure inside it, the Casimir force being exerted on its walls.
And then you compare that measurement to what? What's the control?
You compare it to the standard, well-understood Casimir pressure you would get between two simple flat plates separated by the same distance.
Okay, donut versus flat plates.
If the pressure inside the donut is exactly the same, if the complex curved geometry of the toroid behaves just like the simple plates, then the author's core claim is wrong. The topology didn't matter. The topology factor is a myth.
And the entire proposal dies.
And that's their challenge, right at the end. Compute it. Measure it. If it vanishes, the proposal dies.
But if the pressure is different, if it's measurably stronger or weaker?
If the donut has a unique pressure signature that perfectly matches the Chi-T calculation for that specific geometry, then we have the first experimental proof that shape drives vacuum energy in a non-trivial way.
It's so refreshing, isn't it, to see a theory that actually tells you exactly how to kill it.
It really is. Most fringe theories are so vague, they're always, oh, the vibrations are too subtle, you can't measure them with current technology. This author says, here is the blueprint for the shape. Build it. If I'm wrong, I'm wrong. The data will show it.
I have a lot of respect for that. It's scientific gambling. You're putting all your chips on one number.
It's very high stakes.
I want to wrap up with the last section of the papers, the philosophical manifesto at the end. Because for a document that is so full of integrals and scattering matrices and operators, the addendum after gets really, really deep.
It's all about the shape of nothing. It's the grand takeaway.
The source argues that E equals mc squared is what they call a quadratic relation for free propagation. It's the equation you use when you assume the world is an infinite open road with no obstacles.
But the real world isn't an open road. It's full of walls and corners and containers.
And I love this final passage. I'm just going to read it. The vacuum is not an inert backdrop. It is a spectrum. The spectrum is not abstract. It is boundary conditioned. Boundaries are not decorative. They are causal.
Causal. That's the heavy word in that whole statement. Causal means they cause things to happen. We usually think if a container is just the thing that holds the stuff. The coffee cup holds the coffee. The cup doesn't fundamentally change the nature of the coffee inside it.
But this theory says, no, you've got it wrong. The cup does change the coffee.
The shape of the containment changes the fundamental physics of the content.
And the final line, introducing Chi-T is not a rebellion against relativity. It is a refusal to pretend that a structured vacuum behaves like a free vacuum.
That is the mic drop. It's an accusation. They're accusing the whole of mainstream physics of pretending.
Pretending that the box doesn't matter just to keep the equations simple and elegant.
Exactly. It's a call for what they started with. Honest bookkeeping. It's saying, we know the vacuum is messy. We know walls change its energy. Why are we willfully ignoring that factor in our most fundamental equations?
It's a powerful argument.
It is.
So here's my final thought for you, the listener, to chew on. We spend billions, maybe trillions of dollars designing the materials of our machines, the alloys in our jets, the fuels for our rockets, the silicon in our chips. We obsess over this stuff.
We absolutely do. Material science is everything.
But if this stack of papers is even remotely correct, are we completely ignoring the most abundant design element we have?
Yeah.
The empty space inside the machine.
We might be designing the engine without considering the shape of the cylinders.
If the nothingness is actually doing something, then we have a whole new engineering variable to play with, the geometry of the void itself.
The nothingness is doing something. That's a pretty good bumper sticker for a physicist's car.
I think I'm going to go stare at an empty box for a while and wonder what it's up to. Thanks for diving deep with us today.
Always a pleasure. It was a fascinating topic.
We'll see you on the next deep dive.